students, average velocity and average speed. So in the earlier video, you know what is distance, what is displacement. Now we have to see what is your velocity and what is your speed. What is average velocity? Average velocity is nothing but change in position or displacement divided by time interval in which displacement occurs. So what is this average velocity? Average velocity. This average velocity is what? That is, suppose I write V bar. V bar represents average velocity. So this is V bar is equal to, that is, x2 minus x1 by t2 minus t1. And this is written as delta x by delta t. x1 is the position of the object at time t1. x2 is the position of the object at time t2. So x2 minus x1 is change in position. t2 minus t1 is change in time. So this delta x, that is change in position, that is delta x. This is change in time. So average velocity V bar is equal to this. If you know position, then you are able to find out average velocity. So the unit of velocity is what? Meter per second, because this is meter, this is second, so its unit is meter per second, or you say centimeter per second, or practically one can say kilometer per hour. That means it is frequently used kilometer per hour. Students, this velocity can be obtained from displacement. So velocity is a vector quantity. Why? Because displacement is a vector quantity which is known in the previous video. So since displacement is a vector, so that velocity, or what you say, average velocity is a vector. Vector means it has magnitude as well as direction. So what is the direction? So we should not worry about its direction, because since motion in one dimension is considered, so only plus and minus sign is taken into account. Suppose if in this direction velocity is positive, in that direction velocity will be negative, because we consider one dimensional motion. So you can also calculate velocity like this or average velocity like this. Suppose it is given, suppose the position of the body is given like this. This is 0, I mean this is 1 second, this is 2 second, this is 3 second, this is 4 second and so on. And the position is like that. Suppose this is 2, this is 4, this is 6, this is 8. This is in meter. 6 meter, 4 meter, 2 meter, 8 meter, like that. So how to calculate velocity or average velocity? You consider any two positions. Suppose I consider this position and that position. You may consider this position and that position. One considers this position and that position. Any 2 point we consider. So here this is 1 second means T1 is 1 second. Here it is 3 second means T2 is 3 second. Here it is 2 meter means x1 is 2 meter. Here it is 6 meter means x2 is 6 meter. So what is the average velocity? Here you put this value x2 minus x1 by t2 minus t1. So what it gives? x2 is nothing but 6 minus x1 is 2 by 3 minus 1, 4 by 2, that is 2 meter per second. So students, between 1 second and 3 second, the velocity is 2 meter per second. And what is this average velocity? So one says the average velocity or velocity from 1 second to 3 second, how much? That is 2 meter per second. Similarly, you can consider any other 2 points and also find out average velocity or velocity. Or one says this velocity is nothing but displacement by time. So you see, what is displacement here? So in that example, I explain. Suppose from 1 second to 3 seconds, this. So what is the displacement? Displacement is the shortest path. Initial point is this, final point is this. So from initial to final, this is what? 4 meter. If you measure, this is 4 meter. 2 to 6, 4 meter. So one can say displacement is equal to 4 meter. And in that displacement, what is the time interval? 1 second to 3 seconds, this is your 2 seconds. So one can say time taken by the body is 2 seconds. So what is this velocity? Or you say average velocity, that is displacement by time. One can write like that. Displacement divided by time. So how much? This is 4 by 2. Again this is 2 meter per second. So students, either you take change in position by time interval, or you take displacement by time taken. This is your velocity or average velocity. This is a vector quantity. It may be positive, it may be negative, or it may be zero. One says how it is zero. Suppose a body starts motion from this point. This is the initial position. Now the body moves to this position and again returns to that position. So what happens? Initial position and final position are same. So when initial and final position are same, displacement is zero, so velocity is zero, because velocity is displacement by time. So this is the case of zero velocity. What is the case of negative velocity? Suppose you say one moves in the direction of east. If this is taken as positive velocity, if it returns in this direction, I mean it is west, so that will be negative. One moves along east direction, then it returns to the west direction. That means this is your negative velocity. Suppose one says a ball strikes the wall and returns. When a ball strikes the wall, if the velocity is positive, during return the velocity is negative. So you know positive velocity, negative velocity, and also zero velocity. And how to calculate that velocity, or you say average velocity, through example you also understand. If this velocity is represented graphically, you check. How to represent this velocity graphically? I mean, this is a graph between velocity and a time. Suppose I make a graph like this. This is your time axis in second, origin. This is your, suppose, velocity meter per second. If you draw a graph, the graph is of different nature. Suppose the graph is in this type. So what does it mean? It means with changing time, velocity is also changing. One can say like this. This is velocity time graph. But if I make position time graph, in place of velocity, if I make position time graph like this, suppose this is your position time graph, and I make like this. So my first graph is graph between velocity time, second graph is graph between position and time. But why I compare this? The nature of the graph is same. In first case, with time, velocity is increasing at a constant rate. In case of second graph, position time graph, also with time, position is changed at a constant rate. I mean, for any graph, suppose you take this is x, this is y, and the graph is like that. So what does it mean? It means with changing along x-axis, there is a constant change along y-axis. Okay? For any graph, you can treat like that. So since our focus is on this position time, why? Because from position time, we are getting velocity or average velocity. So if the graph is like that, it means what? Velocity is positive. This graph represents positive velocity. Okay? If the graph is like that, suppose here is a graph, another graph. This type of graph. This is your time. If the graph is like that, I mean with time position is decreasing. I mean when time increases, position decreases. Means what? That is your negative velocity. This represents, students, negative velocity because time increases, position decreases. If I take the graph like this, So what does it mean? With time, position is constant. Position is not changing. So what does it mean? The body is at rest. So if I summarize this, in this graph, your velocity is constant, or one says this is positive velocity. Here this is your negative velocity. Here it is zero velocity. That means from position time graph you can easily know whether velocity is positive or negative or zero. So this is your average velocity. Keep in mind, in this case direction is vital with magnitude. But if we consider, students, average speed, in place of velocity, if you take speed, here direction has no role. Direction is not taken into consideration. So what is this average speed? Average speed is nothing but, if you consider average speed, this is your total distance. You take total distance divided by total time. So how can we define average speed, or how one understands average speed? This is nothing but total path length travelled divided by total time interval during which the motion has taken place, or simply you can say total length divided by total time, or total distance by total time. But keep in mind, here direction has no role. And one says, if the magnitude, if I explain like this, suppose I say a body moves with 10 meter per second towards east. If I say like this, a body moves with 10 meter per second towards east. What does it mean? Or what is given? 10 meter per second means you say this is your speed. But with east direction, one says this is the velocity. So one says a body moves with a velocity of 10 meter per second. Because direction is mentioned. Suppose the direction is not mentioned. Only one says a body moves with 10 meter per second. No direction is given. If no direction is given, only 10 meter per second, whether it is east, west, south, north, nothing is given, then this is your speed. But if with that direction is mentioned, that is your velocity. So one says average velocity will be average speed if the direction is there, or one can conclude that speed plus direction gives you velocity. Speed plus direction gives you what? Velocity. You see, 10 meter per second, that is speed. If direction is mentioned, suppose east, then that is your velocity. Body moves with 10 meter per second towards east means it is the velocity. So I think you understand what is velocity, what is speed, and one can calculate average velocity and average speed. If I consider one example, suppose one moves from A to B then B to C, then C to D. Suppose 2 meter, 3 meter, 4 meter. Here it is 1 second, here it is 2 second, here it is 3 second. So what is average speed from A to C? Total distance. That is what? Total distance means, how can we write? That is 2 plus 3 plus 4 divided by total time. 1 plus 2 plus 3, that gives you 1.5 meter per second. This is what average speed, total distance divided by total time. But if you are told what is average velocity, you can calculate. You just join this. You have to find out this AD, that is your displacement. It has a direction A to D. So you have to find out AD. So what is AD? Through triangle rule, one can find out AD. If you know vector or a vector addition, then one can calculate AD. Then after AD, what is this? Suppose you write what? That is your average velocity, or you say velocity. What is this? That is AD. First to find out AD, whether it is 1 meter, 2 meter, 3 meter, or anything else. From vector rule you find out AD. But for time you have to take 6 seconds. 1 second, 2 second, 3 second. Total time you have to take. So length AD, I mean the shortest AD divided by 6 gives you average velocity. So in this way, one calculates average speed and average velocity.